Okay, so I just want to go over a recap of where we are with our linked integer list. Um, and I set up this document here that goes over the classes and the methods that we've written and are about to write. So the things that we've already done. We created an integer link node class with two public fields, integer data and integer link node next. So it's a recursive field. And then it had four constructors, one for each option of parameters with defaults also of 0 and null. So just going through that code real quickly. For the inc integer link node, we have public integer data, public integer link node next, and then actually up here I had a typo, so it should just say integer link node class to be used by integer link integer list. And then we had four constructors, one that takes the two parameters and sets up a node with a data and a next. And then the other ones have some form of one of the defaults coming in or both of them coming in. Okay, then we set up, you can see on the left, our link integer list class, which had two private fields, an integer link node that indicated the front and an integer size. So go back to that. And these could be downloaded from the in-class code if you weren't around on whenever that was. So this, we're implementing a linked integer list. Linked integer list has an integer link node called front and a private integer called size. We have a null constructor that just has an empty list. So I'm just going to put that comment in there. Constructs an empty list. And then we set up a second constructor that I commented out. In retrospect, I think it makes sense to go ahead and have it. So we'll remove the block commenting there. Constructor that begins with begins the list with a given data value. So you can create a list with a given data value, and that'll just put one node in at the front. Kind of makes sense because sometimes that's a quicker way to do it. That's back over here. So I'm just going to highlight some, well, let's see. So we've got our two constructors. I'm just going to highlight those off. We wrote an add value method that adds node containing a value to the end of the list. So just look at that real quickly. Public void add integer value. We set up a temporary integer link node and put the value in it. And then if the front was null, we set front equal to temp. Otherwise, we need to get through the list, starting at the front and then going until current.next does not equal null. So this is going to end up pointing, current is going to end up pointing at the last node that contains something. Current.next will be null. So the last node will be pointed to by current, and then we can set current.next equal to temp. So that node containing the new values at the end of the list. And then we need to increase the size by 1, which we did. We'll highlight that off. We have not done add an index comma value. We have not done remove the value at a given index. We did do size, which just returns the size. Right here, integer size, return size. I guess I can comment that in. It's kind of self-commenting, but returns the size. Index of returns the index of the first occurrence of the given value, or -1 if it's not there. So walking through that, index of integer value, set off I equals 0. Again, we're going to run through a current starting at front. While current is not null, if the data in current.data is value, return I. Otherwise, current equals current.next and increase I. If you get outside that while loop, it means we didn't find the loop, we didn't find the value, return -1. That was our get index. 2 Boolean methods that we wrote. Public Boolean is empty. We want to return false, true if it's empty. I guess I should say that. Returns true if list is empty. The list is empty if the front points at null, so we can return the value of the conditional statement, return front equals null. Takes care of is empty. Did we do index of? No. Oh, yeah, we did index of. We did not do get index. Sorry, I highlighted the wrong one off here. We did index of. We did contains as well. I'm going to highlight that off. That should return true if the value is in the list. We used index of to write contains because if index of is greater than or equal to 0, it means it's the value is in the list. If index of is negative, that means the value was not. So we're returning this dot index of. Then we don't have to traverse through the list. I mean, it is going to traverse through the list, but we don't have to write that code again. Returns true if list contains value. My cat making a cameo. Yeah. Okay. And then going back over to, so that's what we've done so far. And if I just put some extra comments in, and if you want to pop back, if we pop back over here, we can see what's left to do. This is all done up top. This is all done here. I guess this guy's not quite done yet because we're still working on that. So we've got a few methods here: add a value at a given index, remove a value at a given index. Both of those should throw an index out of bounds exception. Get a value at a given index, that should also throw an index out of bounds exception as needed. A toString method that's going to print a list representation in brackets. And then a couple of private methods that we might want. One, a node at index that returns a node that points at a given index. So if I give you the index, you're going to return the pointer that's pointing at that index. That would also need to throw an index out of bounds, and then check index, which could also throw index out of bounds. So there's a little weird thing here with check index that I've struggled with. And that is that when we are adding something, it's okay to add at the end of the list. So that index there could equal size. But if you couldn't have this index equaling size, and you couldn't have sort of the get index equaling size. So it's a little bit curious how to handle that. So I thought what I would do is go ahead and code them without check index first, and then we can look at what the code looks like and go back and make a check index, basically adjust the parameters as needed for whichever of these guys that's calling it that looks different. Okay, so that's where we are. I'm going to stop the video and we'll come back and do these 4 or 5 methods that remain.